With true ambience rendering, you're always aware of the noise, and after you've performed a few renders and set scenes up and experimented with it, you become gradually aware that something fishy is going on with colour. In this render, what I've done is I've set up these 6 dragons. The first 2 are predominantly red. In the RGB channel they've got 255 red, these 2 have got 255 green, and these 2 have got 255 blue. Additionally, this one has 1 value in red and 1 value in green, and this one's got 1 value in blue and 1 value in red, this one's got 1 value in green, and that one's got 1 value in blue. Now if you look in the reflections, the true balance of colour is more or less seen. This surface here is a mirror that's got a diffuse of black, and it's got metallicity set, so it absorbs a lot of light. White transience light is shining down on this scene, and it's so bright that it's pushing the small values that exist in these colours up to meet the full value. So you see a colour shift. So this is magenta and blue and cyan and all these other colours that don't really truly represent the colour of the surface itself, but have been shifted by the power of the light hitting them. And you see that where the shadow regions are, then you see it's beginning to move back towards the true colour of the surface. So this is an issue, I would say, with the way that the light is processed, the colours are processed, that I've used to my advantage here to create an effect. So it creates quite an interesting effect of modelling and colour shifting on these models. But really we want to understand why this is happening, and if we can understand why it's happening, at least experimentally, then we can try and get around it. Well, if you've been keeping up with the videos, you'll know that I've been experimenting with a new way of generating ambient light for true ambience. I sort of invented, discovered, stumbled over it, and it seems to work much better with colour, and it also seems to reduce the noise. So I thought I would do some tests to try and get to the bottom of, if not why this is happening, at least have some idea of what situations trigger bad lighting effects, and then we can avoid them. So having said all that, we'll move to a much more simple scene to test this. What I've got here is a wall between these 2 spheres. Over one sphere, the sphere on the left, I've got a single light source. It's white, diffuse 25, an ordinary radial light, and on this side there's 3 light sources. They're all set up exactly the same, except one's red, one's green, and one's blue, and they're the same intensity as the light source on the left. And as you would expect, the combined light sources of red, green and blue have exactly the same effect as the white light source on the left, and they're separated from one another with a little wall so they don't influence one another. So that's all well and good, no problem there at all. What I'm going to do now, I'll also mention that the atmosphere is set to black and there's no sunlight, so this is just these light sources influencing this scene. I'm going to go into render options and set things premium effect, true ambience. I'll set this down so it renders a bit quicker, 16 rays per pixel. We'll not use boost light yet, we'll just use scattering correction. I'll turn the ray depth down there. So these are, if you bear in mind, still direct light sources, and as you can see there's no real difference between the 2 sides. You know a difference is going to come because I've set this up with the explanation about how the colours are responding, so you know at some point things are going to change. Right, if we go into the radial light here, edit it and switch it over to true ambience optimization, and I'm going to have to turn the intensity up a bit. I'll go for 200, and we'll see what the effect is on this side now. See if we've got the intensities about right. Okay, you can see in there it's a bit dark, and to compensate for that, although I wouldn't normally use gamma correction, I was very careful about using gamma correction because it does reduce contrast in the scene, and also I think it slightly reduces the saturation of the colours. But so we can see what's going off here. You can see a bit better that now the lighting has changed, and that the rainbow colour on this texture that I show you how to make in another tutorial, I told you it'd be useful, then we're only seeing yellow, magenta and cyan. So if we switch over to this side now and go for radial light red, we'll edit that, true ambience optimised, what did I set it to, 200, okay, radial light green, edit, true ambience optimisation, set it up to 200, radial light blue, edit, true ambience optimisation, set it up to 200. Now in the past, when I've showed you using these lights, I've been very careful to make sure that when I've made a transient light and put it over another one, the surfaces don't coincide. And here you can see on this side that it looks wrong, quite radically wrong. And the reason is this is surfaces are the things that are producing the light. Then if all three of the surfaces coincide, they interfere with one another. So what you need to do is I'll need to make one of these surfaces, so let's see, which one have we got now? Blue. I'll make the blue the larger of the three and the red smaller. So now the surfaces don't coincide, they can operate together. So now we'll render that out, and you can see now immediately something odd has happened here, because you would have expected with the same intensities that even though the colour response, the intensity is causing certain colours to get boosted and come out of proportion with one another, you can see that it's changed here. So the result of the transience lighting here has caused the mixture of red, green and blue all to get pushed up to their maximum values, and only here, where in this strip here where it's magenta, this is because there's an absence of one of the colours, which will be the green in this case. Then you can see that it just gives a strong colour. There's no green in this strip, or very little green in this strip, that can be pushed up by the light arriving on it to make it appear white or nearly white. So this again is a result of the effect that I was using with the dragon image I showed you in the first instance, where the proportion of the colours, even if there's a small proportion of something in one channel, it's getting pushed up by the transience effect to create this change in the distribution of the proportion of the colour and the way we're perceiving it. At this point, what I'm going to do is switch on the boost light and show you something else, which is perhaps explains why the boost light feature has been so supported by Radial in spite of the noise. And obviously you can see there's a lot of noise now. The colour response here is better. It's still close to the light source, getting asymmetrical and out of proportion, but around the edges here we're getting a better representation. But again, there's a peculiarity. Even though we're dealing with the same intensity light source, split in three, and by rights that should give the same response here, it's not. So even though this is better, it's still problematical. So what I'm going to do now is I'm going to switch this back to just a standard scattering correction to ambient. So we're going to lose a lot of that noise. So you notice how the noise has disappeared. I mean, it seems to be slightly more noisy here, but critically, when you introduce the boost light and you're using different colours, the noise levels suddenly jump. And it seems to be that it's the combination of different colours that creates the most noise when you're using boost light. So when you use a high dynamic range image background that's coloured as opposed to monochrome, you suddenly get a lot more noise. So if you start introducing different coloured light sources in a boost light situation, something in the way that the channels are adding up is going wrong, and it's creating far more intensity than it should do for this, and you get these very bright spots in the render. So there's obviously an issue here, since these two light sources should be responding in the same way for it to be a naturally balanced lighting system. So what we'll do, as I was saying, I just wanted to draw your attention to the unusual level of noise that's being generated from the coloured light sources when they're combined. You because obviously that is affecting how it's responding to the high dynamic range image backdrops. If we go to the radial light here, and what I'm going to do is I'm going to swap it over to this gel method that uses the ambient channel, and to demonstrate it's just the ambient channel, I'm going to change the diffuse colour to black, so we know it's not coming from that. You need to go into procedural. It has to be set to normal mode, where transparency must be at 100. We don't need diffuse, we need ambient. And so, having set those things for that light source, the final thing we have to do is make sure we include the background. So this means it's excluding. So we're getting rid of any risk of a diffuse effect from this, even if it was set otherwise. Then that guarantees it. And now we'll see a different sort of response. It's a lot weaker. It's not that much weaker because the light source is quite close to the surface. But in the previous examples, what I've been doing is putting things inside the light source, so it's getting more overall light, but here I'm above it now. At this point, the colour response on this side is very good, so it's changed again. Let's see what happens if we do the same for the light sources on this side. So I'll start with the red light. I'll edit that. I'll set that to black. Use gel, procedural. I want this one to be red. Ambient, ambient and transparent. Set to normal. Set the ambient colour to fully red. Check out of that. Okay, check out of that. And then include only the background. So that's one light source. I'll go to green now. Edit that. Setting that to black just to demonstrate. Use gel, procedural. I want ambient, transparent, normal, and set this one to green. Okay, it's a bit fiddly, but we'll get there. Include only the background. And then I'll select the blue light source, edit that, I'll set that to black. Use gel, procedural, set that to normal, ambient, don't need that, transparent, and set this one to blue. And then in the influence control, include only the background. So now we should have three light sources generating red, green and blue channels separately in exactly the same amount of light as this white light source, which is also generating internally red, green and blue. And now you can see, I hope you can see, is that these are very similar now, or if not in balance. It looks like there's a slight difference, but you have to bear in mind that the size of the sphere, it being the light generating surface, is also going to influence the amount of light that's generated from this. So there is that. And the other thing is, as I often forget, the total effect is being driven by the global ambient colour, and since that's grey as default, it's not providing as much light as it could. So if we set that at fully white, we'll now get more output from that. So there we go. These are looking quite similar, not identical it seems, but pretty close. Let's look at the situation now when we switch to boost light. Before, this was where the real problems were arising with the combined colour effect, and now under boost light the levels of noise are quite similar on either side, so there's not this problem that we were experiencing before, and the lighting's quite similar. With this particular approach, what I've found is that the situation of the amount of light and the distribution of light is much better if you can set it up so that the object itself is within the light source. This may be not the ideal situation for every example, but we'll do that here, and we'll compare the results. So in this situation then, we can see that looking very similar now. Possibly the difference is just due to the difference in camera angle and the way I've set the scene up. And other than the fact that you've got this slight chromatic edge here where you can see changes in colour, because I've had to make the light sources different sizes so the surfaces don't coincide, you can see the results on either side are very similar. So it appears that for light generation from the diffuse channel, either using transient mode with or without the boost light, when you're using different coloured light sources, the way that the light colours are getting combined is out of balance with the proportion of the colour that should be being generated, because by rights, if you're producing red, green and blue of the same value from three light sources, that are in the same place on one side and a white light source, the result should be the same if it's calculating with red, blue and blue. Now what I'll do, and I won't do it here and now because it would only bore you to death, but what I'll do is I'll repeat this experiment with cyan, magenta and yellow, and see if the results are the same, because I don't really know how internally the colours are handled, so it might be worth trying that out and see if the results are very much different, and if they are, then I'll make a video and let you know. So that's that really. That's what I wanted to explain in this ongoing investigation into true ambience rendering with boost light and ambient gel light sources.